that was the integers and text strings. Now we're gonna be writing our first script. So we're gonna put our Python statements in one file so that we don't need to write them again. We can just execute the Python script as many times as we want. And now here at the GitHub repo Python examples, our first script, appropriately enough named first.py. So the Python script files, they should end with the suffix .py. And the Python scripts, like scripts in basically every programming language, they are just raw text, but any modern text editor, and then also here the GitHub is gonna syntax highlight with color and font effects to display the parts of the code. But if you open the script in a raw text editor, you see that there is no formatting there. So this is not Word or a similar rich text format. So all these effects are just generated on top of the raw script by the environment. So reading through the script, let's see what we can find in here. The first thing that we see here is a line that contains this hash mark, octothorpe, whatever you call it. And these are intended as comments for the human reader. Python will always ignore everything. This can never affect the execution of a Python script. So the purpose of these comments is for the human reader. Humans also read code because they need to understand and modify it. The machine doesn't need your comments. These Python statements already say 100% what's gonna happen as far as Python is concerned. So comments are remarks for the human reader, and the comments should never explain what happens because the code already says what happens. The comments always explain why. So in a semantic level that is unreachable from the Python code, for the human explain the purpose of that code. So here we see the example of the names and integer arithmetic, and here we see another example names with the strings. Notice when I'm lazy, I tend to give things one character names, but if a thing represents a meaningful concept in your actual code, then you should give it a name that describes the concept for the reader. The use of a single letter name basically tells the reader that the name is just for the moment and is not itself important. Notice so how because there is two different delimiting quotes, so using one kind of quote, here's the double quote, so allows you to use the single quote inside the string. Now you can always use the Unicode escape to embed any Unicode character inside the string anyway. Now, when a script is being executed, as opposed to the interactive execution, let's put this into the repo, the whole thing. Looks like I copy-pasted a bit too much here. Teachable moment again. And press play. The script is executed and the outputs appear here. The script is gonna be asking for user input. Embedding the results into a string. So what you see here, well, this error here was intentional. What you see in the that the entire script is run without any kind of waiting, unless we are waiting for an input. And then, unlike in the interactive environment, the results of these individual operations are not echoed automatically because the script can easily execute millions or billions of operations. You don't want them all appearing on the screen. So a special function, one of our built-in functions, we're gonna be learning this piecemeal. So we had a len and str so far, and now we're gonna see a print. So print is a function. When you give it something, it echoes that something to the standard output of that particular process. And here the standard output is now coming into this interactive window. So it could be redirected to a file or wherever, so the program doesn't care where its outputs go, but usually the outputs they go to the text console for the human reader. So the print function, give it any kind of a Python expression. Often it is just a one value, like a one variable, but it could be a more something more complicated. That expression is evaluated and printed on the screen. And this one is illustrating the principle from the last lecture. The fact that Python is not a spreadsheet, the names, variables, tomato, tomato, they just remember their current value, but they don't remember any history where that value came from. So redefining variables that appear in an expression that was assigned to another variable doesn't magically change the other variable. Input. Here is, we don't need this in the course, but because of course you wanna be doing these classic exercises, you wanna do the classic please enter your name, and then when you learn the conditional statements, you're gonna make it so that enter the name of the kid brother, so then outputs you are a moron. So this is the classic that everybody did in basic when they were 10 years old. But so this to read input from a user. So the function input, and it receives a text prompt in as a parameter. When you're asking human, tell the user what you're expecting. Don't leave the user hanging. So tell the user enter a name, and then enter the age as a number. But the input, because you cannot stop the user. Even when you're asking the number, the user can still write in hello world, just because to see what happens. So we take the input, it's always a text string, but the function int, so it's like the str that takes whatever you give it and gives it as a string. So this takes whatever you give it and gives it as an integer value. So if you give it a digit string, it extracts the number from the digits. So now we give these names name and age. So then they are, or so GitHub notice even allows us to jump to the occurrences of the name. Very nice. And the f string. So when building up especially outputs, so you can build them embedding the results of the Python expressions inside the string. So your name is gonna be whatever that is, and your age is gonna be, so notice the curly braces don't appear in the answer. Now again, we don't need this one in this course, but there is a Python operator. Notice not the function, you don't use the parentheses. So del makes the name cease to exist. If that's the only name referring to the object at the time, then the object will also exist. But because you can create an aliasing situation, you have several names pointing to the very same object simultaneously. So then the object doesn't go away as long as there is some name referring to it. Once the object becomes nameless, then you can no longer talk about it ever again, and Python cleverly realizes that it has no purpose keeping that taking up memory. Okay, and then we see a new thing in here. So Python has a whole bunch of stuff in the language itself. It's right there out of the box the moment that you start it up. But then there is a whole bunch of useful stuff that is useful, universally used everywhere, but doesn't warrant being part of the language itself, because not everything can be part of the language. There would be too many operators and too much everything. So every programming language, including Python, has what is called a standard library. So standard in a sense that when anybody downloads and installs a standard version of Python, then they're guaranteed that these libraries are there. And then if your script uses these libraries, then the script as is can be run in that other installation, because those libraries are guaranteed to be there. So in the documentation, so this is the documentation, the Python standard library. There some things are built in the language, functions, constants, and data types. And then we have all these Python standard library modules. These are not part of the language itself, but important enough that they are part of the standard installation. And then essentially our high school mathematics as a floating point approximation. So of course we know that the square roots and such are irrational. We cannot exactly represent them in a non-symbolic environment. That we get the results up to the floating point precision. So if I, let's say, import the math, the standard library module, and to access a name that is inside an object. So notice I define the name right here in the repo. Oops. That's what happens with the typing delay. There we go. So name at the top level, so we can just refer to it directly. But when you import the module, so all the names don't get spread out on the top level, because what if you had a name already, it gets replaced there, so then it's just confusing. Now to access a name that is inside an object, so like a module object, so the object dot the name. So sqrt is a function, but because it's a function inside the math module, so we gotta say math.sqrt as opposed to some other sqrt that is somewhere else. So the square root of 2, irrational number, but to the precision that it's possible to represent it in floating point. So the best approximation in the floating point is that much. And importing the math, so here is some other functions. So where any standard library module, you can always look up the documentation. So as you can see, the documentation explains the things that are available in the given module. So there is basically mathematics as it would be in a reasonable high school curriculum, but in a numerical fashion, so no symbolic computations. This is not a symbolic calculator, so you're gonna need a Wolfram Mathematica or similar software for that one. And as a curiosity, so anybody knows complex numbers, so then the complex number data type is there, but it is just a 2 floating point number, so it has all the weaknesses of the floating point. Now when you import them, so as you can see, you can import the entire module and then all the names are inside it. But in many situations you don't need the whole module, then it's annoying to refer to everything through the module name. So if you need like a 1 or a 2 or a handful of names, so alternative form for import, you can say that from a particular module you need only this one. So then this appears to the top level of your current namespace. So the data type fraction, so this is now how we can do the exact calculations. So any decimal number so that is rational can always be expressed as a fractions, but then there are fractions like 1/3. Try to express that as a decimal is not gonna be so easy. So we're gonna be using fractions instead of the decimal number. So everything is integers, as Leopold Kronecker famously said, and then the rest is built on top of that one. So fraction, once it's imported, notice it is not a function. Well, in a sense, but it's not. So then it's actually a data type. And to create an instance of this kind of a data type that you imported, so the syntax is you use the data type as a function, but it's a special function, like when you call it, it creates a new object of the type. And then the arguments, so I want to create the fraction that is -2/7. Now many of these data types, they allow alternative forms of object creation. Sometimes you have a fraction as a string. So here we have a 5/9. So then you could build a fraction that way. Notice you wanna have the string quote marks here, because if you just say fraction 5/9, this becomes first a floating point computation 5/9, and that may or may not be exact. And then if it's not exact, so then you get a fraction representation of the wrong value, and then it's too late. So then it's the fraction has no magic powers to remove the imprecisions. But then the predicting, the way that Python, the way that it works under the hood, is that all these custom data types can be imported, well, not imported, sorry, wrong word, but they can be made part of the language. They're like a native citizens, that just like you can multiply ordinary native integers, notice how you can multiply fraction objects. So this operator multiplication magically, a strong word, but that's what they call it, knows to do the right thing when you apply it to a fraction. Actually, when we pull away the curtain and see the little man, so that the trick is like so simple that once you see it, but everything becomes just the object-oriented method. But the data type, once you import it, some guy wrote this, or some engineering team, I guess could be a gal to this time. So then, so implement it in a way that all these language operators work, and then that's it. So nobody else has to solve that problem. We have this data type that we can use. So now we can, for example, calculate the product of the two fractions. And now that we have a fraction, so here is a classic word problem, famous for the one that anybody who sees this problem will immediately automatically give the wrong answer, thinking that is right. So we have Joe and Mo, maybe they're like a privates in an old-timey military comedy or something. They're in a kitchen, police, and they're peeling potatoes. And Joe is a good efficient peeler, so by himself he could peel all the potatoes in 3 hours. Mo would take 5 hours. So when those two guys are working together, so how long it's gonna take? So everybody automatically says 4. Cannot be correct, of course, because how can Mo be slowing down Joe? Joe already could do it in 3 hours. So the trick is to realize that when we say Joe can peel the entire pile in 3 hours, this is just a way of saying Joe peels 1/3 of the pile in 1 hour. So Joe's hourly speed is 1/3. Mo's hourly speed is 1/5. And these two can be added. So when they're working together, so adding these two fractions is the fraction of the pile that the two men together peel in an hour. And then the time is the inverse of the speed. So the time needed is 1 over together. Notice how the fraction object even works correctly when it's divided by an ordinary built-in integer. Then we get the answer that the Joe and Mo peel the potatoes in this many hours. And a reminder from the previous lecture, so notice strings, the digits 2 is not the same thing as integer 22, so it represents a 22 for us, but as a string, so string is just a sequence of characters, so this means 2, and if you wanna turn it into an integer, so then the function int give it the digit string and it extracts the value. And one last function from the standard library, is it the 5th one or thereabouts, lost count. So there is all these data objects, there's integers and there's strings and fractions that we already encountered, and floating point numbers. Everything inside a computer is just bytes, but the type system in these high-level languages above the machine code level, the processor doesn't know anything about this. So the processor just moves around the bytes in the memory and performs very simple operations on them. And then the Python, all these high-level languages, these get internally converted to a low-level form that can be executed by our computer. So this whole type system is just a fiction inside the language. It is fictional the same way that the hobbits and vampires are fictional, but even when things are fictional, as long as everybody agrees, so we can use them as a shorthand. We describe a character as being a hobbit, whole bunch of stuff is already known, and another character is described as a vampire. The reader already understands quite a lot. So in Python, so when something is an integer, so then Python knows a lot of things about it from that fact that it's an integer. So in Python, every data object knows what kind of a thing it is, and the function type, it's like you're asking the object, alright object, what are you? And then the object's gonna answer. So what is this A? So A is an integer or int. Class means type, as it. So then type, what is B is a string, and then here is so the truth values gonna be important when we do decisions in the next video. So the truth values true and false. So that's the boolean type. So the truth value, to honor the logician George from the 19th century, that the guy who proved that we can build everything in just these two-way decisions. So it's called the boolean, so that's a truth value.